want to start by labeling out our base, our h, and our k. Our base in this case is 2, our h is 4, our k is 1. Remember yesterday we talked about the direction of the graphs. The directions of the graph were dependent upon your base. It was either going to go up and to the right or down and to the right, depending on whether it was bigger than 1 or between 0 and 1. So we go back and double check that, because I kind of forgot. Up and to the right, that's kind of what I thought. So this is going to be an up and right. It's going to do that. So I'm just going to kind of plot that next to it so I remember kind of a general sketch. I have an idea. And we've done that idea of a general sketch before where we plotted with conic sections, parabolas, whatever. We would always go and just make a quick little sketch so we know what direction things were going so we didn't screw something up. Works the same here. So when you go to graph these things, you graph the parent function. We're going to graph the parent function. Okay? And then we shift it. Now, what's nice about the parent functions when you're dealing with logarithms is that you only need 2 ordered pairs. And the ordered pairs that you're going to use deal with the properties of log base b of b is 1 and log base b of 1 is 0. Those 2 properties are the ones you're going to use to plot your points. So all we have to pick for values of x is going to be whatever the value of b is, and it's going to be 1. Bless you, because what is the log base 2 of 2? 1. What is the log base 2 of 1? 0. Your ordered pairs for logarithms will always, always, always be for your parent function. B and 1, 1 and 0. These will always be your ordered pairs. Logarithms are really nice to graph. Okay. Now, well, if they're natural, then what's your b value? E. And E is just an approximation of, was it 2 point something? 2.8-ish. So we just plot it 2.8-ish. Good, that's all that is. So, like I said yesterday, we didn't get a chance to actually talk about how that works, but the reason that works is because when you're working with logarithms, there is only 2 sets of points. Right? There's only going to be 2 sets of points there for us to work with. So from here, we would graph our original asymptote would be at 0, because it always starts originally at 0. We know that we're at 2 and 1, and 1 and 0. Okay. And then to those ordered pairs, I have to move them. I got to go to the right 4 and up 1. So right 4 would be 6, up 1 is 2, 5, and 1. And my new asymptote would be at 4. And away you go. See, well, they're not really that heavy to work with. Yes, ma'am. Sure, absolutely. Do you remember which one? Do you remember which one in particular you want to look at? Does that help with that? If anybody, I'm sorry. Let me just real quick this one. Does that help with any of the fuzziness on the graphing? Natural log is log base e. So your only thing you have to worry about is your b value. Your b value would be e, which we said was like 2.8-ish. Remember which one was it? Sure. All right. Some of these inverse ones. 56. So you're gonna You're going to kind of kick yourself on this one. So when you're dealing with the inverse properties, when you're working with inverse properties, excuse me. Now we've done it this way, right? But you know how to solve that. Inverse properties of these, the inverse of a log is exponential. Yeah. I know. They're inverses of one another. Because what, if you do this, remember the property we talked about yesterday? If I do log base 9 of 9 to the x, what happens? It cancels it out, you get x. Exponential form is the inverse of logarithm. Now, honestly, the only reason we have to know a little bit about that is when we get to solving the equations, which we'll do tomorrow. Okay? And it's so super easy. Okay? Which one? Same basic thing. Here, though, you're going to get, you've got y equals, move this down. Oh. We have y equals log base 7. This can be 7 to the 2x. Okay. Yeah. Here you've got log base e. So then you get, so you e it and you get, what is that? E to the, does that just be x minus 1 then, I believe? I believe that's when you get that one through. Just double check that. So when you do the flip flop on one, like with the natural log, this is where it gets a little weird. So when you have the log base e for natural log, when you do your flip flop, you get that. Now to undo a log, you have to use an exponent. So the property of the inverse stuff would meant that I had to do this. If I do an e to the x, then I get an e to the log. Remember yesterday I talked about the thing called exponentiating? Well, we did. One of the properties we looked at yesterday was b to the log base b of x is x. When the logarithm becomes the exponent and those bases are identical, the x value drops. So this is one of the methods of how to undo equations. As we get to the idea of more of the undoing equations, this becomes more prevalent. So when you get that, e to the x equaling e to the log base e of the jump, what happens to the jump then? It drops down. So you wind up with e to the x is y minus 1. You get y by itself, you get e to the x plus 1 is y. The natural log ones are the ones that look a little weird because you have to remember how to exponentiating thing. And to be honest, like I said, really the only time you're going to have to worry about that is when we work with equations. And as we go through the equation stuff, it is super, 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 super fast. That was 62. Okay, cool. 60. I thought it was, I had, okay. Yeah, it's the natural log ones are the weird ones because you have to do that trick of this what we call exponentiating. I don't even think that's the right word. It sounds good. Bless you. At least it sounds good. Because you're bless you. The what? And what happens is you've got the properties. Remember, the way that the logarithms work, these two, when those two bases are the same, they undo each other. And it lets this drop from just that. Okay. Being able to get an exponent out of the exponent, you'd have to log of whatever the base was. It's how you undo an exponent down. Okay. As opposed to when you know that you had like 3 squared, you know you would take the square root and work your way out that way. But when you have a variable in the exponent, you have to figure out a way to get rid of the base. And that's what logarithms do. They undo bases. Does that help? And you're right, you know the process. Let's do this. One of the things that also comes up with logarithms, excuse me, is that there are a couple of properties that we look at. And I wanted to just open up a second here. Sorry. Got my tickets. Yeah. Sorry. August 18th. Well, good morning. We're doing logs. Remember them? They're big.
Quick, run away. Don't come back in. Turn around and run. Don't come back.
Shut up. You're lucky. Detention slip. You guys don't get detentions. Your dependents today don't need a lot of blood. They're going to rinse you and let you drip. They're going to drip dry you. Universal bloodletting, automotive incinerate, step down, let it handle, let it look. Do you get it? Thank you. It's the end of the world as we know it. Yes, I actually know all the lyrics.
Really? I didn't think anyone else did. I know it makes it
Starts with the earthquake, bird snakes.
But we sing all of
Oh God, I hate that song. Anyway, so what I wanted to do today was I wanted to blend into today just that last little bit. I'm going to give you guys probably 2 graphs for homework, and I want to do some of these what are called properties of logarithms. And in the past, I've kind of gone through this section really, really slowly, and I've done these awful problems. And then I'm kind of looking at our timeline, and we're kind of running out of time to get where we need to be. Because today's Tuesday, Wednesday, Thursday, Friday. Bless you. No school on Monday, Tuesday, Wednesday. So I'm kind of, as I've gone through and looking at where we are and where we should be, in talking with the pre-cal teachers and talking with the honors pre-cal teacher and kind of seeing how crazy do they do properties, they say it's really not hit that much except for when we use them with equations. So I figured that by just knocking this stuff into today, so we're gonna do a couple graphs. So we'll have like graphs and then 8-5 today. Tomorrow we'll do equations, and equations are super quick. I honestly and truly believe we'll be able to review stuff out. It's going to be tight, but we might be able to review stuff out and test on Friday. Yeah, I really do see it. I don't see that being a big deal to get it in there. I really, really don't. Okay? Because I don't, because we have another 3-day weekend. I mean, you guys just had a 3.5-day weekend, which is making this section. So you have this gap, and I'm trying to save some of that through. This will be close to see how it goes. Test-wise, this would be one of those things where, what's that? Yeah, right. No, it would be pretty quick. This is not a very long chapter. Okay. I have said in the past, those principal and interest formulas and those things, I don't require you guys to ever memorize them. I will always give those formulas. I won't tell you which one's which, but I'll give them to you. See where you can at least go from there. So I'll need like the growth formula would be the decay formula, the PERT formula, and the compound interest one. I'll write them all out, put them on the paper for you, but I just won't tell you which one's which. All right. So that's kind of what I'm making it look. So we'll kind of see how it goes. If it has to get adjusted, I'll let you know. But I'm trying to avoid having to push it any further into here. Okay. This is a weird week. All right. So properties of logs. The logarithms there's 3 distinct properties that we deal with logarithms, and it mainly is going to come up when we have equations. It's going to come up when we talk about what's called condensing or expanding logarithms. And what I mean by that is when you have a logarithm, there are specific properties that happen. You get these 3 properties, and like my note to write it on the whiteboard. If you have the logarithm, log base b of 2 things being multiplied together, you can split it apart into 2 separate logs by addition. Yep. Log base b of u times v can be split apart to log base b of u plus log base b of v. I have no idea. P and Q. Well, y is right here. Oh. Log base b of division winds up being subtraction. What's happening here, guys, is that when we get into equations, you're going to be able to combine some of these properties together to solve the equations easier. Okay, it's a shortcut for solving equations. And then the last one is the log base b of u to the n is n times the log base b of u. Now, it looks weird, but when you start putting them together, again, with logarithms, as you might have already noticed, they're pretty easy to work with. Okay. So if I'm looking at this here, going from left to right would be expanding. Going from right to left would be condensing. Yeah. Didn't want to forget. Okay. So expanding goes from left to right. Condensing goes from right to left. It makes it bigger and it makes it smaller. It's pretty easy to figure that out. So if I want to take this, log base 3 of 3 times 9, and I want to expand it. When I expand that, since it's multiplication, means I'm going to add 2 logs together. So I get log base 3 of 3 plus log base 3 of 9. What's log base 3 of 3? 1. And how can I write 9 as a base 3? 3 squared. What's log base 3 of 3 squared? What's 1 plus 2? That's what it allows you to do. Okay? That's what it allows you to do. Or could you have done it a different way? What's 3 times 9? What's 27 written as base 3? There you go. Log base 2 of 4 to the 5th. If I'm going to expand that one out, I'm not going to use the addition or subtraction. I'm going to use my exponent rule, which means as I use the exponent rule, I'm going to put the 5 in front of the logarithm. Five times the log base 2 of 4. And then how do I rewrite 4 as a base 2? 2 squared. So this becomes 5 times the logarithm of 2 squared. Well, what's the log base 2 of 2 squared? 2, which means this is 5 times 2, otherwise known as
25.
Okay. I'm just moving it up to grab another one. There, sir. All right. So I want to rewrite log base 3 of 1/3. That's a division problem, isn't it?
That looks like a 9.
Or if I write this out to expand this out, I'm going to get log base 3 of 1 minus log base 3, 3.
Or
Log base 3 of 1 is 0, and log base 3 of 3 is, which gives you. And does that look familiar as far as your exponent rules? Because if I rewrote 1/3 as a base 3, wouldn't that be 3 to the negative 1? Okay. Yes, ma'am. Yeah, you'll have to know. After you do a couple of them, they're like, oh, that's what it is. They just split apart, and it's the same. Same deal here. If I bring this one over, I get 3. Now, I will say this. When you have exponent and division, or exponents with subtraction, exponent with multiplication, and stuff like that, make sure you put parentheses around everything so you don't accidentally screw something up. You'll get log base 5 of 1 minus log base 5 of 5. Oops. What's log base 5 of 1? And log base 5 of 5? So you get 3 times the quantity 0 minus 1, otherwise known as negative 3. See what I'm saying about it? It doesn't take much to get through this. You're like waiting for something bad to happen, aren't you?
Yes, I am. I'm always alert this time whenever I do not trust them.
Okay. So what I want to do with this one is throw some variables into it, and then I want to expand the logarithm. Reason why we want to learn about how to expand logarithms is because as you get multiple logs, you can start simplifying things out. Again, this is going to be more of a tool for tomorrow when we start doing equations, as opposed to just practicing on it today. So when you look at this, I have log base 2 of 7x cubed divided by y. Now, if I look at that, I have 2 things in the numerator with multiplication. I have 1 thing in the numerator with an exponent, and I have a division symbol for the whole thing. So no matter what, I'm going to have a subtraction at the very end. Are you okay with that? Because they combine stuff. So what we do whenever we have something like this, we have multiple parts in the numerator, you parentheses it. So you'll get log base 2 of 7 plus log base 2 of x cubed subtract log base 2 of y. there's one more step I can do. Which one? There's one property I didn't touch yet. The exponent, right. And I wanted to make sure you guys saw the split apart first. But if you start going through these, you know that you can rewrite it. So I have log base 2 of 7 plus 3 times the log base 2 of x, subtract log base 2. And that's fully expanded. I just wrote it out as 2 separate steps so that way we didn't forget it. I wanted you guys to see that it's still there. Yes. Okay. Not too bad. Really not much to this. No, there's nothing you can do. And again, the reason why we're doing this is because we're going to take large things. We're not graphing anything. No, tomorrow we'll get the stuff that has like an equation to it. We'll have to put it together and put them all together, and it's easier to solve. Yes, sir. Really, the only time that I've seen logs used that you guys will see pretty regularly, AP Chem. AP Chem, and the only reason that I know that is my wife came home from school a couple years ago. She taught AP Chem, and she goes, "What the hell's a logarithm?" I said, "Well," she's like, "Don't give me the long explanation. Just tell me what button to press on the calculator." And I was like, "Oh, she wants help with math," and I'm like, "It is real life, you know. Your wife goes at it." Do that one real quick. Expand. Yes, there's a Z. Oh, and by the way, happy pitchers and catchers report day. Happy pitchers and catchers report day. It's first day of spring training. It's not some random Tuesday I feel like wearing a Cubs jersey. It just happens to be the best Tuesday. That's it. No, there's nothing else you can do. Nope. Good question. Do I have to write base 10 here? No, that's common log. That's where the common logarithm comes from. When you don't see the 10, or if you don't see a number for the base, it is automatically implied that it is base 10, and it does not need to be written. We're getting lucky with it. Okay. Condense. Real quick, the only way that this works is if they all share the same base, and they do, so it'll work. So be careful. Sometimes they will say, "Hey, this one's base 3, and this one's base 5," and you can't do it. They'll just do that to annoy you. Okay. So what operations do you see? Which properties do you see here? There's the exponent one. There's multiplying, and then there's a division. Okay. So, we okay by saying this is log base 10? There's a fraction in here somewhere. My numerator is 6 times what? 6 times 2 squared, which you wrote 4, is all right. And then you're dividing that by what? 3, okay? Which means, what's your answer? What's 6 times 4 divided by 3? Yes, ladies and gentlemen, that's all this is. When you're doing multiplication, it is multiple from left to right, so it's okay. It was 6 times 4 divided by 3. And 4 divided by 3 is 6. I agree. I would like to have parentheses. All right. Condense this one. Condensing.
Progress. Always something. Easy peasy. I got this. Done. Hey, presto, presto. I don't know. Just take the little things that you like and repeat it.
So let's see, we get log base 4 of 5x, y. Oh, real quick, if, and this will show up a little bit more tomorrow. What do you do? Invalid. No, there is valid to it. Real fast, let me show you how this works in a calculator. So, you guys are great. Have I ever mentioned that? You guys are pretty. You guys are all right.
It's guys in the middle.
I'm sorry, you're closer to them. You should move. Alpha window. Alpha window. Alpha window 5. Alpha window 5 gets you to logs. And notice, the cursor is blinking at the base. What number do you think I should put there? And there's your answer. Now, the reason I was showing that real quick is because tomorrow you will have to know how to find that button because you'll have to be able to solve equations. Yes, ma'am. And what I was saying about this whole why do you have to know properties? Well, the reason why we worry about properties is because we can do stuff like this. You'll be able to do stuff like this tomorrow And in order to make this work, natural log is log base what? E. So those two guys have the same log base, don't they? Which means in order to condense them, what would I have to do with them? You multiply. So you would get natural log of x times x plus 3 equals 1. And that's the idea. I'm not going to show you the rest of it, but a lot of times when you have equations, you're going to have to use one of those properties to condense it to be able to get to the next step. And that's what happens. Sometimes you'll have a condensed property that you can expand and simplify parts out of it and then work your way out of it for solving equations. That's why we have these properties. If you remember, when you're multiplying things together the same base, you split them apart by addition. When you're dividing things the same base, you split them apart by subtraction. And then whenever it has an exponent, it just goes in front. It is, and as you guys were saying, going, really all there is? Yes. Some days more than others. Really?
Yeah, you do.
So let's do this. So the graph problems that I want you to the graph problems I'd like you to do are those two because the book does not have a full simultaneous horizontal and vertical shift at the same time, so I just made those two up. And, that should work. All right, so this stops at 54. I actually counted this time, but I want you to do 56 also. Okay. And just so you know, the PDF is already online. Shut up, all of you. You guys are so mean to me. You do know that you could have like gone to the old tech, the other part of the web, and that's fine. It's resourcefulness. It's good for you. Have you learned that sometimes I'm not? Well, I don't mean to. I just get busy.